Hello again, everybody. Here we are with another lecture, and this time we'll be just continuing on with this linear equation trend that we've been talking about, and we're actually going to start graphing these equations today and look at some nice and common formats for linear equations that can help us graph things a little bit more easily. So just to start off, let's go ahead and recall just some of what we've talked about before in this idea of what these linear equations actually are. So we've got several different examples here. They all look pretty much the same format. This is a common format that we'll see for these linear equations. So yeah, just some examples here. These should be pretty familiar. So let's go ahead and talk about an extension of what we talked about last time, where we said, hey, if we want to graph a linear equation, let's actually just find 2 points for that equation, and then just plot them on a graph and connect them, and then hey, you have a line right there. If I recall, we did that with 3 points, but we actually really only needed 2, because then you can just draw. You sort of connect the dots right there with just those 2, and that gives you a line. So there are 2 points that we'll tend to actually find, other than finding just any random point. We tend to find the y-intercept and the x-intercept, and what we mean by that y and x-intercept, that's just the values that occur when you are on the axes. So for example, this y-intercept, that's going to be where the line crosses the y-axis. So that would be right there for this red function that I have. Let's put some labels here as well. Y, x, there we go. So for this red line that we've got this circled in orange right here. We've got that y-intercept. And so as you can see, that y-intercept is going to occur when my x is equal to 0. I don't want to move at all left or right. I just want to start right here at the origin, want to stay where I am in the horizontal direction, and I just want to move straight up to that y-intercept. So we can find this algebraically by taking whatever line we have, in this case y equals 3x plus 4, and we can just set x equal to 0 and figure out what we get for y. And so when I do that, it should be very, very clear here that we just get 4, right? 3 times 0 plus 4, this term goes away, and we just get the 4. And so that tells us that that value of that y-intercept right here in this orange right there it has a value of 4, and the coordinate point would be 0, 4. I'll say equals y int. So that's my coordinate point for the y-intercept right there, and that's great. We have 1 point already on that we know it satisfies this linear equation. We have a point on the graph. So now we can find the x-intercept, and again, just for a quick sketch here, let's graph the same thing. We've got this red line. The x-intercept now, again, I'll circle that in orange. That's going to be where the graph crosses the x-axis. And likewise, we're just going to set y equal to 0. If you see here, if I start at the origin, I want to move horizontally to wherever that is on the, wherever I intersect the axis. But then I don't want to move vertically. If I move vertically, that's gonna take me off of that axis, and I don't want to do that. So we want that y value to be 0. And so this will look a little bit different here. When we start with our y equals 3x plus 4, we're going to set y equal to 0. So now we have to do a little bit more manipulation. We have to actually solve for x. And so I'm going to start off by actually from this step here, I'm subtracting 4 from both sides. I do rewrite that a little bit differently. Maybe I could put an intermediary step where I say -4 equals 3x, and then I just flip that equation around, just like we've talked about before. We like to have that x on the left-hand side. So then I divide both sides by 3, and we get x equals -4/3, and that right there is sort of this length right there, that -4/3. And again, when we write this, we want to make sure that we're writing it as a coordinate point. So for x, -4/3, and then for y, 0. And there we go, we get our x-intercept right there. Make sure that for any coordinate point that you're writing, make sure you actually write it as a coordinate point. You write it with these parentheses, with our comma right there. Maybe we're putting x and y right there. It's very, very, very common for students to take a y-intercept and just say, oh, the y-intercept is 4. Boom, and we're done. But you got to remember that y-intercept, that x-intercept, those are coordinate points. So make sure that you're always writing it in that coordinate point format. All right, so at that point here, if we were trying to graph this function, we would have 2 points. I won't do this super detailed, but let's just sort of sketch this really quickly. So we've got our x-intercept was at -4/3, 0, and our y-intercept was at 0, 4. So we've got these 2 points. Let's go ahead and just mark 4 and -4/3 here. I won't bother with a whole bunch of tick marks. And then basically we're just going to connect these. Just go ahead and make sure that actually lines up right there. That's good enough. Great. And so we've got a line right there, and more importantly, we have the x and the y intercepts here. And so boom, we've got our answer right there. Y is equal to 3x plus 4, and that's a great graph of it, except that we do want to make sure that we have labels. Don't forget those. So we've got a nice graph right there that gives us a lot of information. So there we go. Awesome. So we've kind of seen this over and over. I've never explicitly said this, but we've been looking at this for quite a while now. And this is what we're going to call slope-intercept form. So let me actually jump back to a previous slide where we saw these examples of linear equations. And what hopefully you can tell is that all of these look pretty darn close to this y equals mx plus b that I keep writing over and over. And here we'd have m is equal to 6. Here we would have m is equal to 3/2. And here we would have m equals to -2. So that m just being, hey, whatever that number that's multiplying x is. And then b would be, in this case, -3. In this case, +1. And in this case, +4. You want to be careful on this first example here. It is a -3, so we want to make sure that value b is -3 here. And so we've seen this on a lot of our linear equations. We've pretty much written exclusively in this format. And there's a reason for it. This format is nice. This format, we call it, like I said, slope-intercept form. And the reason we call it that is that if you have a linear equation written like this, you can identify without any work what the slope and what the y-intercept is. And so, like I've said here, m is that slope of the line. And it turns out, this probably shouldn't be that confusing, this should be fairly obvious, that the value of b gives us that y-coordinate of the y-intercept. And so again, just to reiterate what I've said, we would say the y-intercept is equal to 0, b right there. And now, like I said, this should be fairly obvious if we look at this work here. If I have y equals mx plus b, remember, we find the y-intercept by setting x equal to 0. So if I set x equal to 0, well, it doesn't matter what m is. M, for whatever number it may be, if I multiply it by 0, I'm just going to get 0. So you get b for that y value of the y-intercept. And so as I've said, we get 0, b for that slope, or for that y-intercept. So any example that I give you you can, you can just look directly at it and tell me what the slope and what the y-intercept is. So here you could say, hey, the slope m is -3, and the y-intercept would be 0, 2, because b would be 2. Now, be careful. If I give you something that looks like this, you got to be careful there, because that's not written in in slope intercept form. Slope intercept form is y equals mx plus b. And while this does look similar, my x and my y are flipped. So you always want to make sure that you do your slope intercept form when you've solved it exclusively for y, and that you've expanded everything out, that you have things in that mx plus b format. Constant times x plus another constant. If I gave you something, we'll see this later. If I gave you something like 3 times x minus 2 plus 5, a lot of people would say, oh, great, okay, m is equal to 3 and b is equal to 5. But that's not quite correct, because in this case here, we are not in mx plus b format. We have this x minus 2. So we'll see more examples of this. We'll see a bunch of examples on the worksheets of how we have to get it in this form as well, before we can carry on. But let's go ahead and talk a little bit about what we actually mean by this slope. So I've said over and over, hey, m is equal to this, m is equal to that. But what the heck do I actually mean by m? What is it? What is a slope actually? And well, a slope just has to do with how steep a graph is. Are you walking up a really steep hill, like a mountain, or are you walking on a very shallow inclined road or something like that? That slope just tells you how steep it is. And there's a formula that we can use for it. And we have a formula here. I don't want to emphasize this too much yet, because I think it'd be more beneficial to look at a graph first. But we do have a formula. So let's just say that we had 2 points that we know lie on the graph. For example, maybe the x and the y-intercept. They don't have to be those 2 points, but we've talked about how to find those. So those are good points that you could start with. But if you have 2 points on the graph, and I'm going to call those points x1, y1 as the first point, and x2, y2 is the second point, you can use this formula, and that'll give you your slope. So let's go ahead and actually look at an example of this. I have a line right here, and it would definitely continue on past where I've drawn it here, but I'm just noting this segment of the line between -3, -2 and 2, 3. And so what we're doing here, when we actually plug into this formula for m, we're actually finding sort of the ratio. Remember, we've talked about ratios as being fractions. We're finding the ratio of y2 minus y1 to x2 minus x1. But and to say that sort of shorter and quicker, we're finding the ratio of how much this graph changes in its height, which is just the difference in these y values. You could count 1, 2, 3, 4, 5. Notice that I end up with a 5 up here on the top. And then you're looking at the ratio between that in the blue and how much you travel horizontally in the red. And again, you could count 1, 2, 3, 4, 5, and notice how we end up with a 5 here on the bottom. And so what we're looking at here with this slope, and it makes sense, right? If you think of something as being really steep, that means that if you move horizontally, you're going to move a lot vertically, and that's going to give you a larger value for this fraction here, because if your change in y is a lot more than your change in x, then you have a larger number on top than you do on bottom, and that's going to yield a larger final value. And so what we see here when we plug everything in, we're going to take our y values, which are 3 and -2, and we're going to just subtract those from each other, and that's going to give us 5. You can see that work simplified down right there, just looking at the numerator. And again, that's just that counting. That's me counting how many am I going up, right? I have my 1, 2, 3, and then I have going down -2, so I have another 2 that I have to go down, and that's 5 in total. And then same exact thing with the x2 minus x1. I am taking the difference between 2 and -3. That's exactly what you can see on the bottom here. I get 5 as well. And so we have this sort of counting of five sort of tick marks, if you will. Just to be clear here, there's a nice way that you can remember this formula: rise over run. And so I've explained this without using those terms explicitly, but that rise over run is just going to be, how far do I go up? How far do I rise? And how far do I go horizontally? How far do I run straight across? So rise over run is a great way to remind yourself of this. And one last thing to note while we're here, we've sort of looked at all of this in this sense of going across and going up. And so, we can see that we're gonna, tick along our flat slope, or our flat horizontal direction where we're running, and then we're going to rise up in that vertical direction. But just to be clear here, when we get this slope of 1, we should get that slope no matter what points we use. So what you could tell here is that if I go, let's say I go over 2, and then I go up until I meet the function. Well, I went over 2. I should definitely go up 2, because in that case, my rise over run would be 2 over 2, which is 1. And let's do this in a different color. Let's go over 3.5. Well, if I go up, oh, look, I went up 3.5. And then here I went across 3.5. And so my rise over run would be 3.5 over 3.5, which again is 1. And so this is a cool thing about the slope of something like a line. It doesn't change. It doesn't matter where you are on the line. It doesn't matter what 2 points you look at. You're always going to get the same thing. And that's a great way to check your answer, is to actually do this formula for the slope here. Do it twice with different points if you have multiple points that you can use. And that's a great way to check your answer. So a lot there on slope. Just mainly remember rise over run. You're taking the difference in the y values and the difference in the x values. And so let's go ahead here and do an example. We're going to start off with 2x plus 4y equals 3. And I want us to find the slope, the y-intercept, and the x-intercept. And since we don't have a graph of this, it should be pretty easy to find the slope and the y-intercept, because remember, we have that point slope format. We have that y equals mx plus b that we can refer back to. So if all we have to do is take this take this equation that we have for this line and just rewrite it in that format. And let's go ahead and do that. So if I subtract 2x from both sides, I'm going to have 4y equals 3 minus 2x. And then just to be good, we're going to write this the opposite way, just going to flip that around. Then we're going to divide both sides by 4. And remember, when I do that, I can treat it as though I'm dividing each term on the right-hand side by 4. And we'll do one last step of simplification there. We've got that -2/4, which is the same as -1/2. And boom, we have got the equation of our line. Should be fairly easy to recognize the slope and the y-intercept here. So we've got that. Our m is going to be -1/2, so we know that that is our slope. And then likewise, our b is going to be 3/4. So remember, we write that in the ordered pair, 0, 3/4. That's our y-intercept right there. Now, to find our x-intercept, as we said, we're going to set the y value equal to 0. Because we already have it written in this format, I'm going to just do it right from here and solve for x, just set that y equal to 0. You could do it from here, and that's perfectly acceptable. Either way works, you'll get the same answer. But just because I already have this written in this form and I don't really want to go back and look at the original form that we had it in, we're just going to set that y value equal to 0 right there. And when we do that, we're going to take this guy, we're going to add 1/2 x to both sides, and then I'm going to multiply both sides by 2, and that turns that 3/4 into 3/2. So that's our x value. That gives us our x-intercept of 3/2, 0. And now, let me be clear. We could have calculated the slope in a very different way. So we turned this into point slope form first. Or excuse me, I misspoke there. We turned this into slope intercept form first. But we didn't have to do that. We could have found the x and y intercepts first and then calculated the slope based on that. So let's just recall we have an x-intercept that we just found of 3/2, 0, and we have a y-intercept of 0, 3/4. And now, as we've said, we can take any 2 points on a graph, and we can calculate the slope from those points. So if we've got that sort of rise over run, right? Let's give ourselves some labels. I'm going to call this x1 and y1. I'm going to call this x2 and y2. And now it's just a game of plugging and chugging. So we've got y2 is 3/4. y1 is going to be 0. I've got an x2 of 0 and an x1 of 3/2. So at this point here, I have 3/4 divided by 3/2. I like to write that out as 3/4 divided by 3/2, which I can write as 3/4 multiplied by the reciprocal 2/3, and that's going to end up giving me 1/2 right there. Oh, and I dropped the negative sign here just to be clear. I'll put it in a different color. Let's put it in green. I dropped the minus sign right there. So that minus sign gets carried all the way in there. Yes, so got that minus sign there. That's because it's 0 minus 3/2. And we get our same slope that we had before, and we should expect to get the same thing. So a couple different ways that you could do this problem. There we go. Now, let's do it. Let's look at an example where I'm actually giving you a graph. And here I want us to find the slope, the y-intercept, and the x-intercept. And you might just look at this and go, oh, well, that's easy. Let's just look here at the y-intercept. Let's look at the x-intercept and do what we just did on this last example. Write them down and just find my slope. Well, here's what I would say. That's all fine and dandy, except when I look at these x and y intercepts, and let's zoom in a little bit, that to me, those 2 points don't look like something that I can very easily say what they are. You might guess, oh, this is about, a fifth of the way through. This is maybe halfway, maybe 2/3 of the way, but there's no definitive place to say this is exactly where it is. So we have to get a little clever here. And what I actually want to do is I actually want to calculate the slope first. And so what I do notice here are 2 points. I notice 1 point right there, and I notice 1 point right there. And those are easy points for me to actually calculate and calculate a slope between, because I can just see that this point here is -1, 2. Let's go ahead and write that down. And then this point here is going to be 3, -1. So I've got those 2 points, and I can very easily calculate a slope. Once we calculate that slope, the question on our minds is, well, how the heck am I going to figure out what the y-intercept and the x-intercept are? We'll get to that, actually. Let's calculate this slope right off the bat. So we've got here m is equal to y2 minus y1 over x2 minus x1. Let's give ourselves some labels here. x1, y1, x2, y2. So we're right back onto this plug and chug. y2 is -1. I subtract off y1, which is 2. X of 2 is going to be 3, and I'm going to subtract off that -1. I like to put that in parentheses just so I don't have two negative signs right next to each other. I've got a -3 over 4, and right there, that's actually just our slope. We've got a -3 over 4. Let's rewrite that, make that look a little better. And boom, we have a slope. So this is all great. This is fine. You know, we've got 3/4 x plus b, but we don't actually know what b is here. And so there's two ways we could do this. Both I would actually say are pretty clever. One is that we actually know points on this graph. We have 2 points right here. We could use either one of these points and plug them in for this x and for this y, and that would leave us with only the variable b, and that would actually give us our value for b. Let's go ahead and do that just off to the side right here. So y equals -3/4 x plus b. We can write it off like this because we know what our slope is and we don't know what our y-intercept is. Let's use this point right here, the x1, y1, and let's actually plug in for that x and the y. So that -3/4 times -1 is just 3/4. And then when I do 2 minus 3/4, I'm going to have 8/4 equals 3/4 plus b. So then 5/4 equals b. And that's wonderful right there. Now we actually just have the equation of our line. I'll kind of sneak that down over here. Y equals -3/4 x plus 5/4. Now, this was kind of a lot of work. When we look at all of this, I mean, we had to find 2 points on the graph. We had to calculate the slope between them. Then once we had the slope between them, we had to actually go through and use one of those points on the graph to actually find the value of that y-intercept right there. And at this point, we still don't even have the x-intercept yet. And so there's got to be a quicker way of doing this. And there actually is. I've actually misspoken a couple times during this lecture, and I hope I've caught myself every time. Where I've meant to say slope-intercept form, I've said point-slope form once or twice, and that's because there actually is another format of a line that we haven't really seen things written in, but it's actually more common than slope-intercept form. And I personally think it's a bit more useful. And so this point-slope format, as you can see, it looks different here. It looks different than what we saw before with y equals mx plus b. We've got this sort of x minus x naught in here. We still have a slope, but here's the difference is that let's say that we have a line and we know what its slope is. We know that its slope is m, and we have a point that lies on that line, any point that you want. We can write this in what we call point slope form, where my m just gets plugged in right there in a very similar fashion to slope intercept form. And this point here gets plugged into the x naught, y naught that we see here. So let's go back and let's look at this example here. So we've got this graph right here, and let's use this right here because it's a little bit cleaner. We don't have as much written on it. We had this point that was -1, 2, and so at this point here, what we could do is we could just kind of look at our rise over our run, and we could say, hey, look, I go 1, 2, 3 down, and I go 1, 2, 3, 4 across to the right, that's going to give me a slope of -3/4. If that's tough for you to see here on just doing this sort of making this triangle, if you will, if that's tough to see, you could do the calculation like we did before. We did that all right here. We found our slope of -3/4. Well, once we have that slope, we're done. We can just write the equation of this line and without even having the y-intercept, because we can write y equals -3/4 x plus b. Oh no, we don't have the y-intercept. So let's go ahead and write this in our point slope format. X minus something plus something. And these somethings are that x naught and our y naught. Well, that's just a point that lies on the graph, any point. And so I can plug in that -1 and the 2, because that's a point that is a x comma y that satisfies this equation. And then at this point here, we can just simplify. And this right here is a perfectly acceptable format for the equation of the line. You do not have to simplify it to slope-intercept form. You can if you would like, and if you do, you're going to get the same thing that we got before. Let's go ahead and show that work here. Distribute out this -3/4. And again, we're seeing that 2 minus 3/4, that gives us that 5/4 again. And there we go, the same exact format that we had before. So 2 different types of formats for the equation of a line. We've got the slope intercept form named in the pink, named as such because by looking at it, we can immediately find the slope and we can immediately find the y value of the intercept there. And then in the blue here, we have point slope form, which again is called that way because we have a point that we can very, very quickly identify. Be careful of positives and negatives here. Remember that we do have the format x minus x naught, so you got to be careful there. And again, finishing off why we call it point slope form, because we have our slope of -3/4 right there. Both are perfectly acceptable. Both are useful. If you have a y-intercept, it is great to just write your line in this format, but we don't always have a y-intercept as the point was made in this example right here. You can't always just read off what the y-intercept is, and so it might be a lot easier to just write it in point slope format, because then once you have it in point slope format, you can very, very quickly turn it into slope intercept form. So a lot of good stuff right there. I will mention that we, on this example, I actually didn't go through and find the x-intercept, but we've done that a handful of times. In either of these formats, you would just set y equals to 0 and solve for x. I won't bother doing that here. I'll leave that for you to do. But we'll go ahead and call that for the lecture, and just grind on that point slope form and that slope intercept form.